Alright, here we go, but it looks like for some reason my video's frozen, so let me try to figure that out. There we go. Alright. 3.3 practice problems. Let's run through these pages 104 through 105. We're doing the evens per usual. For questions 1 through 6, it says classify each slope as upward, downward, vertical, or horizontal. So based on the last lesson, you shouldn't really need to graph anything on these. Just need to tell what it is. So let's start with 2. Ilm, remember what does ilm mean? It's a shorter way of writing slope. It's our variable for slope if you want to think of it like that. Ilm equals 7. So if we have a slope of 7, is it an upward slope, a downward slope, a vertical, or horizontal? Well, hopefully you remember that positive slopes are upward. They are sloping up. 4. -7. Well, if positive 7's going up, -7's going down. And remember, it has nothing to do with what the value is. It doesn't matter that it's a 7. We're just looking at the sign on these. Number 6. -5/4. We don't care about the 5/4. The negative sign tells us that we're going downward. Great. For questions 7 through 27, we got a lot of practice for calculating slope based on 2 points. I don't want you to be intimidated by this procedure. It's something that's going to become very natural to you. We're going to be using it a lot in a lot of different scenarios as we learn more math. So just get comfortable with just writing out the formula. Take it long. Take your time. Don't try to do this in your head. Write out the steps because look at this. This is what 15 practice problems that you'll be doing for homework. If you can do it the long way well, the more you do it, the better you'll get and you won't make any errors. The goal is to do it right the first time, not to do it fast. Plenty of people think they do it the right way, but they don't write it down and they do it fast and they get it wrong and that causes more problems. Take the little bit extra time it takes to write it out because you're almost guaranteed the right answer every time. So I'll do the evens. You will be doing the odds of these. I'll start with number 8. Alright, let's run through these. Number 8. Alright, we want to write our formula. y2 minus y1 over x2 minus x1. Alright, our second y is 2. Our first y is -5. 2, negative, use parentheses, it'll help you out, -5. Okay, so we got a negative. Second x is -2. First x is -3. Here we go. So we got 2 minus -5, which is just 2 plus 5 is 7. And then we got -2 minus -3, which is -2 plus 3, which is 1. So we got a slope equal to 7, or 7 equals m. Alright, next one. Our formula, y2 minus y1 over x2 minus x1. Our second y is 2. Our first y is -4. Our second x is -4. Our first x is 2. 2 minus -4 is the same as 2 plus 4, which is 6. -4 minus 2 gives us -6. 6 divided by 6 is 1. With the negative gives us -1 equals m. Alright, set up our formula. y2 minus y1 over x2 minus x1. Alright, our second y is 2. Our first y is 6. Our second x is 3. Our first x is 0. 2 minus 6 is -4. 3 minus 0 is 3. We can't simplify that. We got -4 over 3. So we got a fraction as our slope. That's totally fine. Because what this means is, remember when we wrote out our 2 points, or if we had a point in a slope, we start at 1 point. The -4 tells us we go down 4. So we go, well, let's use this slide right here. So if we have the point right here, we got -4 over 3 as our slope. -4 says go down 4. 1, 2, 3, 4. And the 3 tells us go over 3. 1, 2, 3. -4 tells us go down 4. 1, 2, 3, 4. 3 tells us go over 3. 1, 2, 3. That's how we read fractions. It's just telling us how many we go up or down and how many we go left or right. So we see we got a negative slope because of our negative line right there, or a negative sign right there. Okay. All right, write our formula. y2 minus y1 over x2 minus x1. Our second y is -4. Remember, parenthesis, parenthesis, first y is 1, second x is -1/2, first x is 2. We got -4 minus 1 just gives us -5. -1/2 minus 2 means we're going even further, so we got -2.5. So we got -5 divided by 2.5. Couple things we can do here. We could do keep it, change it, flip it, if you wanted, or we can just change the denominator, so it's a whole number by multiplying everything by 2/2. That would give us 10/5, or -10/5 over -5. These cancel. We're left with 10 divided by 5 is 2 equals our slope. All right. If you don't understand why this works, just think about what this 2/2 means. Okay. Right, our formula y2 minus y1 over x2 minus x1. Our second y is 3, our first y is 7, our second x is 5, our first x is 9. 3 minus 7 is -4, 5 minus 9 is -4, -4 divided by -4 gives us a +1. And then this one over here. Right, our formula, y2 minus y1 over x2 minus x1. Our second y is 6, our first y is 5, our second x is 8, our first x is -4. 6 minus 5 is 1. 8 minus -4 is the same as 8 plus 4, which gives us 12. 1/12 equals our slope. Same interpretation, that just means we go up 1 and over 12. So that one's going to be kind of, if we only go up 1 and over 12, we're going to have a line that's kind of shallow, or a shallow slope. It's going to be shallow. Yeah, so that's another good point. The bigger the denominator, well, if we have a fraction with a big denominator, it's going to be a shallow slope. If we have a big full number, a big numerator, it's going to be a steep slope. So something you can keep in mind. All right. First, write our formula. I didn't do the colors on this one, so sad. Here we go. y2 minus y1 over x2 minus x1. Our second y is 4, our first y is 6, our second x is 8, our first x is 3. 4 minus 6 is -2, 8 minus 3 is 5. We can keep it like that. It's our slope. So that means we go down 2 and to the right 5. We're going to formula y2 minus y1 over x2 minus x1. If you're not writing your formula on every single problem in your work, that's not good. I should see you starting with this formula in every single one of these problems on your homework assignment. Okay? It's important. You may not think it is, but I know it is, so you're going to do it. Okay. All right, our second y is 7. Our first y is -4. And remember, we need these parentheses too, because that helps separate our negatives from our negatives so that we don't get any confusion there. Parentheses are not always necessary, but they do keep organization, so that's why we treat them like they're necessary. It's better to be organized and redundant than unorganized because we miss stuff. So redundancy helps keep organization, usually. I mean, usually in the real world. It does in our cases. Our second x is 3, and our first x is -1. 7 minus -4 is the same as 7 plus 4 is 11. 3 minus -1 is the same as 3 plus 1, which is 4. 11 over 4 is our slope. That means we're going up 11 to the right 4, or if you're counting in the other direction, we're going, so let me visualize it, going up 11 over 4, or if we wanted to go the other direction, we can go down 11 to the left 4, because in this case, they're both negatives, they cancel out. Left is the negative of right, down is the negative of up. Okay. And now over here, write it, 2 minus y1 over x2 minus x1. Second y is 5, first y is 5, second x is that, what did I write? Is that a -3? Yeah. -3, first x is a half. 5 minus 5 is 0. Do we even need to proceed? No, because once we see this numerator equal to 0, it doesn't matter what the denominator is because this top is going to be 0 as well. Therefore, we've got a slope of 0. I could have gone the whole way, but I didn't want to. I mean, you can, once you see that, you know it's 0, but let's just do this. -3 minus a half would have been -3.5, in case you were wondering. Alright, we got a couple more, but I didn't make slides for those. I'll go ahead. Oh, wait, maybe we only had one more. Yeah, I'll squeeze it onto this page in an annoying way. I'll use green because Tanner hates green. Alright, we got -4, -1. We've got -4, 3. Y2 minus y1 over x2 minus x1. Second y is 3. First y is -1. Second x is -4. First x is -4. Honestly, I don't know if I've been saying that in the right order this whole time. Keep track. If you've been keeping count, let me know what my count is of mistakes I've made saying that. But 3 minus -1 is the same as 3 plus 1 is 4. -4 minus -4 is the same as -4 plus 4, which is 0. Oh, denominator of 0. What does that mean? We can't divide by 0. Undefined. Undefined. What does that mean? What does our graph look like? It means we have a straight graph up and down. And we can see that because in this example, our x values were exactly the same. The only way we can have the same x values is if we have a straight line. Same thing over here. If we notice for this, we have the same y values. The only way our y values are the same is if we have a horizontal line, which is why we have a slope of 0. Okay, for questions 28 through 31, we got something a little strange going on. So, it shows us that, what? They haven't even explained that yet. Hold on. Okay, I'm calling bullcrap on 28 through 31. They have not taught you, how to answer. Well, 1, it's kind of unnecessary. 2, they skipped ahead a lesson. This isn't something you should see until next lesson. And it's not even that complicated, it's just, they could have waited. Anyway, okay, moving on. Okay, it says graph a line through the origin using the given slope. What's the origin? That's where the x and y axis meet. That's right there in the middle. What's its coordinates? 0, 0. I did that thing again where I was typing with a P and then started recording. Sorry. Dang it, keep doing it. Ah! Anyway, back to this. So we want to start at the origin, so let's make a dot at the origin, and we want to graph a line using the slope. We saw how to do that in the last lesson, so let's use this. We're doing the evens, so we'll be doing 32. I did tell you to skip the last problems, right? The 20, if I didn't, skip 28 and 30. But because you skipped a problem, no, I'll just go ahead and show you both. Okay, so it gives us a slope of 2. So our slope is equal to 2 in this case. So how do we find other points? Well, we can treat this 2 as a fraction 2 over 1, and that tells us our rise is 2, our run is 1, so we just need to count up 2, 1, 2, over 1. There's a point right here, and we'll mark that. And then up 2, boop, boop, over 1. There's another point right there. What if we want to go down? Well, we just treat both of them as negative. Or flip the signs, you might say. Flip the signs is more general, and we can use that in other cases. So just flip the signs, -2, -1. So now we're going down 2, 1, 2, left 1 right here, down 2, left 1 right here. So we got our nice little line. Woo, woo, woo. All right, 34, we got -2. So let's do a different color. We'll start in the middle right here. Our slope equals -2. Make that a fraction by putting it over 1. So -2 says we go down 2. +1 says we go right 1. Down 2, 1, 2, right 1, right here. Down 2, 1, 2, right 1, right here. If we want to go in the other direction, flip the signs. That's why I said do flip the signs, because now we got +2 in the top, -2 in the bottom. That tells us we go up 2, 1, 2, we go left 1 right here, up 2, left 1 right here. Don't draw these little clouds that I'm drawing in between dots when you graph. I'm just doing it because I don't want to switch between the laser pointer and the pencil. Anyway, there we go. For questions 35 through 40, we're basically doing the same thing we just did, but instead of starting at the origin, we're starting at a different point. I'll only do one example because you can figure out the rest because it's basically the same as what we just did. Okay, so they gave us the point -1, -3, -1, -3 is right here, and they give us a slope of 1 over 3, 1/3, so we go up 1, we go up 1 over 3, 1, 2, 3, up 1 over 3, 1, 2, probably right here. So we got a shallow slope. Remember, it's shallow if we have a much bigger denominator than our numerator. It's steep if we have a bigger numerator than our denominator. Anyway, yeah. And now we'll skip to the next bunch of starting at 1. Alright, the instructions for 1 through 6 are solve each equation and check for the solution. Solve means get x by itself. So, we got our problem. Is there anything we can simplify on the left? No. Is there anything on the right? No, because there's no like terms. But we do need to get all of our x's on the same side. So we can do that. We can move our 2x to the left, so we can subtract 2x on this side, subtract 2x on this side. That leaves us with a -6 on the right. And we didn't touch the 5. But 3x minus 2x gives us 1x. To get x by itself, we subtract a 5, subtract a 5. That gives us x equal to -11. Alright, over here. No like terms on the left, no like terms on the right. We do need to get our x's together, so let's move our 4x over by subtracting. -4x, -4x. This cancels, we're left with -8. We didn't touch the positive 4. 6x's minus 4x's gives us 2x's. 2x plus 4, we gotta subtract the 4. We got 2x on the left, -8 minus 4 is -12, divide by 2, x equals -6. Alright, take a look at this problem. What's special about it? We've got ourselves an absolute value. Remember, we can't do anything with an absolute value until we get the absolute value by itself. Even though we're trying to solve for x, we gotta deal with this first. So let's think about how we get the absolute value by itself. So what's happening to the absolute value? Getting multiplied by 7, getting added by 8. So we're undoing, so we need to do our PEMDAS in reverse. So we'll do addition subtraction first. These cancel. We're left with 7 times the absolute value of 5x plus 6 equals 22 minus 8 gives us something 14. Alright. Now what's happening to our absolute value? It's being multiplied by 7, so we'll divide by 7, divide by 7. We're left with the absolute value, 5x plus 6 equals 2. Remember, absolute values work differently than parentheses. What do we got? We got parallel lines, so we're going to make parallel universes. So we got one example where we got 5x plus 6 equals 2. We got another where 5x plus 6 equals -2. Let's solve both of these. To get x by itself in this one, we do -6 minus 6. We're left with 5x equals -4. Divide by 5, divide by 5. We're left with x equals -4 over 5. Nothing we can do to simplify that. And then on the right, -6 minus 6, we've got 5x equals -8. Divide by 5, divide by 5, we've got x equal to -8 over 5. So, two values of x that make this original statement true are these two. Let's go ahead and work it out. -4 over 5. 5's cancel, we're left with -4 plus 6 gives us 2. 2 times 7 is 14. 14 plus 8 gives us 22. So that one works. -8 over 5. -8 over 5. The 5's cancel, we're left with -8 plus 6, which gives us -2. Absolute value of -2 is just +2. +2 times 7 is 14. 14 plus 8 is 22. Checks out. And then lastly, we got 8 and 10, which are word problems. Number 8. At class meeting, Jeff, Chad, and Lane ate a total of 254 marshmallows in the marshmallow eating contest. What? That's crazy. Jeff won by eating 7 more marshmallows than Chad, who ate 5 more than Lane. How many marshmallows did Jeff eat? All right, let's write down our sentences. So in total, they ate 254 marshmallows. So in the total, what? The total of the marshmallows that Jeff ate plus Chad ate plus Lane ate. Remember, JCL does not mean Jeff, Chad, Lane. Variables have to represent quantities. This is the number of marshmallows Jeff ate, the number of marshmallows Chad ate, the number of marshmallows Lane ate. They're not representing the people, they're representing the marshmallows they ate. So we know that total is J plus C plus L, which they give us the number 254. It's important that you understand how to get totals, okay? Next sentence they give us. Jeff ate 7 more than Chad. So the number of marshmallows Jeff ate is 7 plus the number that Chad ate. Who ate 5 more than Lane? Who is referring to Chad? So Jeff won by eating 7 more than Chad, who ate 5 more than Lane. So the number of marshmallows Chad ate is 5 more than the number that Lane ate. And we want to know, how many did Jeff eat? So, one way, I'm done here by the way. One way to do this is to ask ourselves, in the sentences we have, which variable shows up the most? Well, if we look, in all 3 of our sentences, we have the variable C. So it's actually going to be most useful if in our totals equation, we convert our other letters to be in terms of C. In terms of C just means that's the variable we're using. So we see already that J equals 7 plus C, so we can make a substitution. So let's do that. Instead of writing J, we'll write 7 plus C plus L equals 254. But how do we change L? L isn't by itself, so we can't make a substitution. Wrong. How do we get L by itself? We subtract 5. So let's do that. Minus 5, minus 5. These things cancel. We're left with L equal to what? Read this in English, C minus 5. C minus 5. So we know that we can substitute L to be C minus 5. So rewrite everything we have except the L, which is now C minus 5, equals 254. All right, simplify. Nothing to distribute on this one, so we can just drop the parentheses. 7 plus C, and then we have to distribute a positive through here. Positive times positive C is positive C, positive times negative 5 is negative 5. So we'll write plus C minus 5 equals 254. Oh, I don't know if you can see this anymore. Hold on. Oh, yeah. Hidden is a 7 plus C. All right. So now let's combine like terms. We got C plus C plus C, which is 3C, and then 7 minus 5 is 2, equals 254. Minus 2 gives minus 2 gives us 3C equals 252. Can you still see that? I hope. Yes. All right. To get C by itself, we divide by 3, divide by 3. That equals C, and then take my word for it. It equals, or do it in your head, 84. So if C equals 84, are we done? No, what are we trying to accomplish? How many did Jeff eat? So let's use the sentence that uses Jeff and Chad. So substitute the C for 84. J equals 7 plus 84. 7 plus 84 equals 91. So the number of marshmallows Jeff ate is 91. What about Lane, you might ask? It doesn't matter. The question didn't ask for that, so we don't have to get unnecessary information. If you really wanted to know, you could plug this and this into our equation and then up here and then figure out what L equals. But we don't need to know for this case. We just care about Jeff. And then finally, we got 10. Several members of Bethel Church spent 17 days on a tour of Israel, Egypt, and Germany. That's a weird combination, isn't it? Israel, Egypt, and Germany? I don't know. They spent twice as long in Israel as in Germany and 3 fewer days in Egypt than in Germany. How many days did they spend in each country? Alright, so similar thing as before. Let's start with our total. So they say they spent 17 days in total. So 17 is equal to Israel plus Egypt plus Germany. But remember, these don't represent Israel, Egypt, and Germany. They represent the number of days they spent in each of these countries. Make sure when you first write down your variable, you know what value it's representing. It's not representing a noun, it's representing a quantity. Quantity. If you need to, write off to the right, I equals number of days in Israel, if you need to do that. But you just got to make sure you separate those, make that clear in your mind. So they spent twice as long in Israel as in Germany. Okay, so rephrase it a little bit. The amount of time they spent in Israel was twice the amount of time they spent in Germany. And then they spent 3 fewer days in Germany than they did in Egypt. So rephrase it, the amount of time they spent in Egypt was 3 less than Germany. So, just like in the last problem, these are all our sentences they gave us. What variable is in common? We got a G in all of them. Even though that looks like a 6, and that actually they all look like 6s. It's a G. Okay, so we want to do our substitution again. So 17 equals, instead of I, we can write 2G. Remember, use parentheses. And instead of E, we can write, we can write G minus 3. They already put it in terms of the variable for us. That's nice. Okay, and then parentheses. Don't forget the parentheses. And then plus G. All right. 17, there's no nothing to distribute on this first one, so we can just rewrite it. Distribute a positive, so that's just going to be positive G. Positive times negative 3 is negative 3 still, plus G. Dang, that time I literally just wrote a 6. That's my bad. I was thinking about 6s. All right, combine like terms. 2G plus G is 3G, plus another G is 4G, and then we have our negative 3. And now we just need to get G by itself. So we gotta add the 3 first, add the 3, we got 20. Oh no, I'm off the screen again. So we got 20 equals 4G, and then divide by 4, divide by 4. We get 5 equals G. What is G equal? The number of days they spent in Germany is equal to 5. So we got G equal to 5. We need to know the others. So Egypt, all we got to do is substitute the 5 right there. 5 minus 3 is 2. So the number of days they spent in Egypt was 2. And then they spent twice as many days in Israel's Germany. 5 times 2 is 10. Israel equals 10. Does this add up to 17? 10 plus 2 plus 5 is 17. Good. In this case, we did need to calculate all 3 because that's what the problem asked for. So, yep, just write your sentences, take your time, think about it, substitute. You got this. All right, that's all for this video. Bye.